And the first item I'll link into what we're going to talk about on the presentation. I've got it split up into it looks like 3 sections, and the first one is going to be about really supply chain. So I'm going to be looking at supply chain from a Chinese supplier of a wireless chip. So I was in a meeting with the CEO of one company in New Jersey, and he's my client. And he was in some big discussion with I was sitting there listening to this big discussion going on about, should we really use this Chinese part as a key component? It's a, I wouldn't call it a single chip. It's really a SoC. It's a system on a chip. So there's multiple cores. There's all kinds of good stuff on it. It's high frequency RF. It's some digital DSP processing. There's plenty of correlators to do DSP work. And there's things like full GNSS receivers built in on the same POC. And so it's a very complex integrated circuit. And so the argument is this: do we really want to buy this part from China? And, you know, the risks that immediately come to mind was supply chain. You know, the idea that if the supply chain has to be obviously a constant source because it's their main chip on their whole system. And they've designed an advanced tracking system. So it uses cellular. It's a full cellular design, but it's built in to handle the narrowband NB-IoT and LTE-M. So they have the narrowband low power wide area network capabilities built in. And it's a pretty cool chip. But somebody have the other risk is let me go forward a bit here. Yeah. So it's not just the supply chain risk, but it's obviously a lot of other things, because I looked at the president and he says, "Do you want to work on this project?" I said, "Yeah, sure. I'll lead the project, and we'll because this is like an interesting project because I wanted to see what the viability of a Chinese supplier." I was aware of all the problems with Huawei, you know, the US had with Huawei, and what the problems were with Huawei base stations. You know, you probably are very familiar with the Huawei story, right? I won't go into the Huawei story, but I don't want to duplicate that with Quectel. So Quectel is the name of this chip supplier in China that I told him I'd be happy to look into it. In fact, one of the VPs of sales is an American friend of mine, so I could pick up the phone and call him and get information if I need to be. So they have, you know, why the chip is built by this Chinese company called Quectel. My buddy, there's quite a few Americans in some leadership roles, but certainly not the CEO of the company. And I'll get to that. But okay, so this is a communications SoC supply risk analysis, which has gotten very important lately with the total tariff question too. So this is good timing on this to wrap this project up. And then the second one is general, what's the state of the art with IoT security? And I open up the Spectrum window where you can see things coming in real time. If I got captured slides, but if it looks like the browser is working, I don't know, we'll bring up the browser where I can communicate directly to the server and decode the IoT traffic that is seen in my Hamilton Square house location from my lab in Hamilton Square. And the third is the aircraft, the communication risks in today's aircraft, and there's the 4 techniques of communication that they use between the aircraft is sending via RF. And you can take a look at that. That's interesting too. And I dug a little bit into the risks with the aircraft communication, lack of authentication, and so forth. And then I have some IEEE articles I read that shows what their suggested direction is. A couple authors suggested ways, and I'll go through the ways of cleaning up the spoofing problem, and then the authentication problem with aircraft communication. And then finally, what Dennis's favorite is this drone detection and what's going on in drone. And you ain't kidding, Dennis. There's a huge war going on right now in the Ukraine. And this is, I mean, I started looking at some of the literature, the armament literature, and this is like a field day. So if you have a drone you want to test out, we can put it in the hands directly in the Ukraine. Now it's a killing field right now, so it's a little bit scary, you know what I mean? But they're testing all the advanced drones and the hidden drones. They have ways of hiding electromagnetic, shielding it or not seeing the electromagnetic emissions. And one of my careers many years ago, I worked on Tempest spec. The Tempest spec is the side detection of RF. So it's a side, you know, unintended radiation of noise. Only it's not noise. It's that you can apply coherent demodulation if you know how to do it or what it looks like. But anyhow, so I'm going to get a little bit into that. I don't know how much time do I have, Dennis?
Oh, you can go for a while here.
Oh, okay.
Maybe about 10 after 9.
And I don't want you, if you have any questions, this looks like a small enough group, we can be interactive. So if you want to jump in, share your experience and your experience or whatever, you know, because I look at this as a discussion. You know, I'm not doing this as a formal event here. All right, let's jump in. The company's name, I'm not going to go into too many details that are company specific because I did this on a consulting contract, so I have to be careful. I've taken out most of the 30+ pages in my report. So this kind of gives you the whole lay of the land though. So my first thing I want to do is where's the IP licensing on this chip? You know, whose IP are they using? And do they have a license for it? Well, they do have the Qualcomm MDM 9205. That's their IP license for the LTE-M chipset, and with IoT built in and GPS and all the good stuff in it, GNSS. And then I looked at the license and I said, well, the question is this right away, if I'm looking at alternative sources, I want to know who else is licensing their IP. Now, the way Qualcomm sells IP is you have to buy their physical chipset from them. They ship you a bag of chips that make up the SoC, but you put it together and you manufacture it with their IP is in the parts basically that they send you the chipset that makes up the SoC. So they have an identical chipset, MDM 9205, Qualcomm license at Telit and Thales. I think they are also joined forces with Centurion. Anyhow, so that's good news right away. I told the president, I said, well, there's a glimmer of hope here because you've got multiple sources. Not quite true in the end, but I'll tell you why. All right, so in this particular license, the Telit one is made in the country of origin is always a big deal too. So where's it made? So it's assembled in China on the Quectel, of course. Other ones are made, and the Telit's made in the Siemens lab in Germany. And then there's other foundries that they use in Vietnam, Taiwan, China also. So there's a problem here we're going to get into. So right now, the production lead time is 8 weeks. Now, in this particular slide, I'm talking about Telit. So I'm looking at them as an alternative to the all Chinese Quectel. So, you know, everything's good. I buy the development system, got it up and running, great, wonderful standard AT instruction sets. Plus they have extended to do, you can do your own measurements of the cellular parameters that you're interested in. And you could pull out a lot of the pilot signals of the local base stations and take a look. Okay, so this is what the Qualcomm, it's the LTE modem CS architecture. So these are the basic components. I'm not going to get into all these layers, but my client is using this for LTE-M. We've looked at, I personally have looked at this same chipset and using it, and I've tested it for NB-IoT. I only had one vendor offer NB-IoT around here. It seems to be You know, you could get LTE-M, almost every base station supports low band LTE-M, which is great for good penetration, you know. The lower frequencies, narrow band is the way to go if you want long distance and low power. NB-IoT, and then that's the narrow band IoT. That's the most narrow one, but I can't buy it from. I haven't looked the past month or so, but it was not unavailable. Other than T-Mobile had it available as an experimental usage only. Okay. And I couldn't figure out. I still can't figure out. I think it's a pricing issue because it's heavily. We use LTE-M heavily for IoT now. It's pretty much a standard. For cellular IoT, what we see is the whole world seems to be LTE-M in the US. The rest of the world, Asia, is all NB-IoT. And the big advantage they get is very low cost. So my guess is that the carrier doesn't want to go bottom basement and charge less than $1 a month per IoT device. They want to go above that, which they could do with LTE-M. LTE-M is faster, but quite frankly, in IoT, you don't need it faster. Well, now lately with IoT coupled with machine learning, you can be slower than slow. And if you know Shannon's equation, you know, I go super narrow bandwidth, these guys can do anything. I mean, you know, 15, 18 kilometers, no problem at all. Whereas LTE, I can go 1 kilometer. I can narrow the bandwidth and then go 15 to 18 kilometers, piece of cake, and have better penetration, you know, earth penetration and concrete penetration, which is the area I've been doing research on, is concrete penetration. Okay, so that gives you some idea of where we're at with that. So the other thing that was nice is I got some development boards from Telit also. And so let me just tell you what happened with this whole thing. So I had my feelers out and I started to look at I went into some of the armament shows in Asia. Now, I can't read Chinese, but what I can do is use the translators. You know, so I was looking at QuickTel's propaganda, sales propaganda, and I was getting it translated. So now, knowing they have this Qualcomm license, there's a couple ways of viewing that. One way to view it is they're trying to learn enough to copy it and throw Qualcomm. Second of all, which I know they did for a fact, was they learned all about NB-IoT from that. And they found there's a lot of the licensing is not covered by Qualcomm on NB-IoT. So they seized they purchased or just took over the IP and NB-IoT. So everywhere in Asia, especially China, you see NB-IoT. Very low cost support service and very good distances because it's even narrower than LTE-M. Which I would call, it worked out very well. I tested it. Areas in my basement, I use as my Faraday screen room. So if I'm using T-Mobile, I'm in my basement, and I pile bricks and on top of the antenna, and I try to sandwich the antenna, shield it as much as I can. Well, my phone doesn't work at all. My T-Mobile phone doesn't work. No connectivity, zero connectivity. I take the antenna off this board, which I did, and I put it under piles of concrete, and it worked perfect. Got great signal to noise ratio, no problem. I could have dug a hole in my basement, it would have still worked. I had it at a 18 dB advantage with NB-IoT over LTE, so an 18 dB improvement in link margin, which is huge. I mean, that's just unbelievable. Okay.
What is like the bandwidth?
15 kilohertz. It's narrow band. Yeah. I mean, it's not LTE. What's LTE? 25 megahertz. But so here's what's happened. So I started digging into the literature, and they kept bragging about NB-IoT, really downplaying. Now they have their own foundry set up to do NB-IoT chips. There's no licensing. They pay Qualcomm on NB-IoT. So they're trying to move all the customers to NB-IoT where they don't have any licensing. no intellectual property, no licensing. And so there were strong showings at these conferences and shows in Asia where, like I say, they're pushing away LTE-M and 5G, 4G, they don't care. For IoT, they don't care. I don't care either, quite frankly. But so I got the feeling they weren't, long-term Qualcomm licensing partner. I got the feeling they're going to bail as soon as they can, hopefully legally. And then the backdrop of this whole thing, their pricing was much cheaper than Telit's system on a chip. So they were trying to aggressively drop their price to the point where we would go with them. So then I looked at second tier, I looked into the foundry. Well, unfortunately, they are all using the same foundry for their chips, which is the Taiwanese TSMC. Well, this is not really great when I have to assure my boss, you're going to get parts. No, you ain't going to get parts when they're going to go invade Taiwan. It's not going to happen. If they do, I hope they don't, but I don't know. There's a lot of activity going on right now around Taiwan.
You kind of want to have a South Korea supplier, right?
Right. So when you think about risks in a supply chain, I want something in South Korea. I want something in Vietnam. That's hard to believe, but Vietnam is great. All of a sudden, they look pretty good right now.
Yeah. 30 years ago, you were looking at Northern Ireland.
Yeah.
Yeah.
So my end report said, I'm really skeptical of this. This is not, I don't think it's a good long-term relationship. I think that the Telit service is great. I'm used to Telit. I bought lots of parts from them when I worked for General Electric. This is a good partner to have. I'm not real thrilled about QuickTel. And they're like, well, we get such great prices from QuickTel, And so then I always I have an alert set. Now I have alert set, so whenever there's news about QuickTel, it alerts me, right? It goes to my mailbox. You have an alert. So literally last month, I get an alert, and it's from a DoD source. And congratulations, QuickTel, they made the banned Chinese company for the U.S. Why are they banned? Because upper management is all People's Liberation Army or
Party folks.
The party, yeah. I mean, serious party folks.
Serious. Yeah.
I would say
I'm a party guy myself.
Yeah. Yeah, but you don't believe in the Chairman Xi's philosophy, right?
No.
You got a problem with that, right? But anyhow, that's by the way, you always look at, when you try to analyze leadership, I always, like when I did a report on the Enigma system in Great Britain, many years ago in England, when they cracked the code, they're like, well, we always hear the name Alan Turing, right? So he's the hot guy in the block. Where did Alan Turing go to get his computer working? It didn't work, by the way. So he went to a guy called Gordon Welchman, who was in Hut 6. So that's something I always ask now. We have a historian in the group, but he doesn't like my methods, but I like to find out who they consider a role model,
Mm-hmm.
So President Xi's role model, who do you think it is? Who do you think the role model is? I mean, you guys know, I unfortunately learned about Chinese history pretty late in the game. I read a lot about, Chinese history just to give the contract, give him a good deal on the contract, but.
Not Al Gore?
Well, he's the inventor of the internet, right?
Yeah.
Oh, man. But yeah, his role model is Mao Zedong.
Yeah.
Mao Zedong is a brutal, sadistic killer. He ruled China by terror, pure cutting bodies up, killing people in front of large towns, terror. So would that want to be your role model? This is the guy I'm not going to trust, right? So anyhow, so I was thinking for a last minute, gee, do I want to this is the end of my contract. I'm going to send a note to I'm gonna send a note to the president of the company. I'm gonna say, they're now on the banned list. You're gonna be using, you can't use a part that's on the banned list now. DOD's is like Huawei, you can't do business with them. So they said, thank you. That's all they said to me, you know. Fortunately, my contract was just over, and so anyhow, that was my news. Okay, so let's talk about IoT. IoT is, when I think about the state of IoT, a lot of IoT uses the ISM band. ISM stands for Industrial, Scientific, Medical, it's freebie. You know, when I talk about cellular, NB-IoT, and LTE-M, it costs money. Especially LTE-M is a little bit more money. It's cheaper than LTE, but it's not quite the same price, like I say, NB-IoT or LoRa in this case. So at 433 megahertz, I see a lot of international satellite that's testing LoRa protocol at 433 ISM. And then the stuff we did on a grant with the college in New Jersey was using LoRa. And we were trying to see how much penetration we got in concrete. I teamed up with a professor of civil engineering. He said, let's see how many pounds of concrete we can put around the antenna. So we were doing all those experiments, which was very, very interesting. Anyhow, so what I did is I set up in my lab, I set up a Spectrum server. So I can be anywhere, I can be here, right now, and go to my live real-time Spectrum server. And I can go to a tab I set up that I can demodulate anything coming up, mostly anything. A lot of stuff is not encrypted. In fact, everything you're going to see when I go live is not encrypted. So here's an example. If you look at this, here's the security server. This is on my neighbor's safe probably. It's called DSC security, but there's an ID in this left corner, and then you got all the activities, what's closed, what's not. ESN, which sounds like a serial number to me, and then you got events, testing of the battery. What do you want to do in a security system? Well, you want to make sure the battery's still alive. Somebody cuts your cable, and then there's who manufactures advanced safes? I can't remember the name, but anyhow, they come across the company that makes advanced wireless safes. Now, this isn't exactly, I can't go open their safe with this information, but it shouldn't be on the free airways for anybody to look at either. You know? Yeah, same thing here for WWIII tower is actually no problem because this is a temperature. You know, there's these Oregon temperature sensors you buy for these towers that have the airflow meters and everything. That's listed here too. This is WWIII tower. This weather, so you only see the weather outside. And you see bunches of those. So I just had this on just before I came over here. So I kept this on because sometimes when my neighbor starts his car, I get this message here with the ESN number of his car, and then things like his pressure, temperature of his engine, battery status in terms of 1, 2, 3. So every time the guy starts the car, I get this message.
And he has a Citroen.
And he had this isn't exactly subtle, right? I wouldn't call this encrypted. But now, so this question in something in my mind thought, well, I know they've cracked basically stealing cars. The gang in Philadelphia had figured out how to go down a block and then start cars and drive off with them, steal cars. So the way they did that, you can look it up, it's on public domain. So when somebody starts their car and they're using a fob, an encrypted fob, there's a rolling key. So the rolling key says it has to match, obviously, the receiver in the vehicle, but rolling meaning it's a finite amount of time and then it rolls. So it becomes a different key, right? So if you spoof it out, if you send the key in right away, when you see this, you can take control of the car. So apparently you can still do that. Now, I haven't tested that firsthand, but you know, you can get the rolling key through monitoring this, the 433 ISM spectrum. Not that I want steal anything in my neighbor's yard or my neighbor on my left works for Bloomberg. He's head of security. So it's kind of interesting, at least to see what he's got going over there. He's got a few safes that's anyhow. But this is not good. So what I'm seeing now in IoT is it's free flow. I'm not seeing any encryption here at all. This stuff is all looks like I shouldn't say all, but what I'm seeing here, there's a lot of stuff that there's no encryption at all, which is not a good feeling. Because if I went back a year ago, I would have less traffic. It would be the same thing, it'd be unencrypted, same as it is now.
Dennis,
So-
quick question for you, Dennis. Can you hear
Yeah.
me okay? What is the
Yes,
brand?
we can hear
What
you.
is excellent? What is the brand of the SDR software that provides all this detail? This is very nice.
It is very nice, yeah, I'll talk about that, yeah, in a minute.
Excellent, thank you.
But it's called Open Web SDR Plus. Open Web SDR RX Plus. There's an RX on the end. And what it is a very interesting code. It was designed by a Hungarian amateur radio buff, but he did all this for his master's degree. So he's got a cool environment. So he's running all the user interface on the browser. So the user interface is a browser with JavaScript. So if you're running JavaScript on your browser, all modern browsers have JavaScript, you're running the whole user interface. So all it has to do is send the IQ, in phase and quadrature, RF signature, right? And then he can do all his decoding on the SDR on a separate board, right? So he started out with a Linux system. I ran the Linux code. Since then, he left the program, so it was forked off, and then next thing you know, there's a whole group in Europe that picked up the code, and they kept building on it, this Open Web RX, SDR RX, and they kept building on it. So now it's incredible stuff. So is this a good point? You want to go live to it? You want to see what the neighbors, if he's starting his car
Oh,
or truck? There's another one in there with a truck.
if we don't get into trouble with Princeton University security folks, let's do it.
I don't think so. If the
Yeah.
alarms are off, we all run.
Yeah, they're all
I
on.
don't know you, Dennis.
Okay.
Okay, I'm gonna switch to, can I automatically share to the browser?
Yeah.
Okay, so I've got this Open Web SDR. I had it running on my Linux system. Runs perfect. And they keep building decoding routines. So it's up to over, I'm gonna guess 35, 40 decoders of the digital traffic. It looks at it and decodes. There's a long list of
You want to put the.
the one we were at, that page, yeah, that one page.
I get it. I get it.
It's pretty cool.
Yeah.
So this thing is just an incredible amount of software. You can go to it, you can take a look at it, you can download it. And one of the things I did is I took it, once it's running on Linux, I ported it, somebody ported it, I didn't port it directly, but they ported it to a Raspberry Pi. So I built it running on the Raspberry Pi, runs perfect on a Raspberry Pi. Raspberry Pi 3B, it runs perfect. And okay, so this is the live feed from Hamilton Square. Okay. So if you go like APRS, that's an amateur radio protocol. Let me move this window out of the way. There's something really cool here. Okay, just for fun. So what I've got here is a whole bunch of, I have V3 SDR that's plugged in. This is an inexpensive software-defined radio. It's It's a small dongle. It goes for what, about 35 bucks, 30 bucks you can buy it for. And if you look at what I'm sliding my mouse down, there's all these different protocols. So I have a bunch of, here's the AM broadcast band I put on that. But check this out. So here's AD. Anybody know what ADSB is? Okay. I'm gonna get into that. So this is the latest aircraft. This is the latest aircraft. Now, when I click on it, look what pops up. So this is from literally measured from the receiver, which happens to be on the antenna on my roof. So this has got in distance what the airplane is. So when I see the airplane under 10 kilometers, I could literally go see the airplane if it's at night. Or you can see it, you could link into the plane spotter, and then it links right into that, which is amazing, real cool stuff. So this is a live feed. So where this came in very helpful was when the drones were invading New Jersey. I could sit there with my binoculars. I got a high power binoculars. For some reason I don't have a telescope or can't find it. But here's one 14 kilometers. You can get very close. You can get 1 kilometer in some cases. So here's an 8 kilometer. So if I wanted to see where that plane really is, other than go outside, what the thing I could do here is click on aircraft. Okay. So this is the aircraft, and here's the flight plan right now. And here's the speed of the aircraft. It's all coming from ADSB. It's called ADSB. And here's the acronym. Anyhow, so you've got the plane, and then underneath that you've got, okay. So he's just taken off from what airport?
Kennedy,
Kennedy, yeah.
and he's 2 hours late.
And he's 2 hours late.
Yeah,
Yeah, so he's going to Dallas, Fort Worth.
yeah.
But here-
I've been late going to Dallas before.
But now this is what this keyed off of the plane it actually seen, right? In real time. I just clicked on it. It went to this software package, which is the FlightAware, excuse me. FlightAware, it links automatically to FlightAware if I just click on it. And then it shows you, this is pretty cool because it shows you the altitude and he's going 409 miles per hour. And he's just taking off, it looks like, right? Because the bars is where his stable flight all the way to Dallas is his goal here. That's in his flight plan. But you can see you got the speed now real time. The other link, this is cool too. Check this out. This is really cool. So if you want to actually see this flight, oh, where did it go? Let's pull up something. Oh yeah, here it is. Oh, here it is. Now 12 kilometer. So let's click on the link here. I just clicked on the flight link. Okay. Okay, now this is interesting. So FlightAware says this is a no visible. We're not going to tell you who owns this. And meaning if it's a corporate president, he does not want to know. He doesn't want the public to know he's on this flight. So or he even owns this flight. Yeah. Right. It's got all the transponders, right? You see, you got all the transponders, except Air Force One, the president they turn off the transponders in certain patterns. They're not going in the Middle East with all the transponders on. It's like, hey, I think that's Air Force One. But there's something else here. Let me just show you. Anyhow, so this is, I'm going to get off the track here. But this is real interesting. And it links in the software. The guys actually linked it up. And there's something else here I'm going to show you. Okay, so this is back to open web. Oh, the distance. Okay, this is what I want to show you. Okay, so this is 10 kilometers. So let's click on the word distant link 10 kilometers. Is that linked? Yeah. There it is. Okay. So this looks like a mess, right? Let's close this one out. And then you can zoom. So you can do a zoom. So this is 10 kilometers of my roof, my house. This is N1724U at 9 kilometers. So he's 9 kilometers from my roof. And so here again, you got the aircraft, the registration number, but now they link it in real time and you can see all the planes now. This one's coming up over my house in a little bit. Looks like he's aiming right for my house. But you could track these flights so these are linked live. And I'm getting this stuff in real time, right from RF. So there's nothing between RF and I'm looking at it directly. Now, some of the there's other fields and some other tracking protocols I could show you where there's a room where the pilot can type a message. So I could see all the pilot messages going out. Like I have an engine failure. I've seen that middle of the night. I'm getting some work done. I'm like, whoa, engine failure. But these pilots, no big deal. Especially if it's only one engine failure. Who cares? They type it in. Right, exactly. And so that's this protocol. Let me show you what that protocol is. So this is let's see here. ACARS. Okay, VDL2 is another aircraft one. There. Okay, so this is the other aircraft one, but there's room in here for typing messages. This is called ACARS. It's older than the ADSB, but ADSB is the latest. But you see, this is the spectrum. So I got the spectrum window here. I've selected VDL2 protocol at this spectrum, at this frequency at 136.1 megahertz. And then you see so you're decoding this. I don't think this is encrypted, but this is, I don't know what we call this. There's a secure versus encrypted. And, but you could see right away when the pilot, I think the pilot types things. Or if they have an unruly passenger, they'll type it in, arrest this passenger when we land at LaGuardia or whatever. But we see all the planes coming in. Let me get this out of the way here.
Yeah, don't click on that. There you go. Click on that one.
This one?
Yeah.
Yeah, good, thanks. Yeah. Okay, so you got this is the newer, but not the newest protocol for the aircraft. So aircrafts are still using this. And they have international frequencies and then they have domestic frequency. And this stuff goes right to the control tower. So the control tower is watching all this stuff. If you want to see the actual signal, you look up and that's the signal. So I got that window right under there that I'm looking at, decoding. Any one of these planes, you can click on this flight, for example. And that's en route from Fort Lauderdale to New York. So why am I seeing that in New Jersey? You can see there's the path. You can see the path coming right up over New Jersey. It's not really it's too, doesn't have a right contrast, I don't think. Can you see it now, the different states?
He's on final approach. He's gonna land at 9:02.
Yeah.
Hey, you see where he was circling?
So if you got nothing to do, you can watch this all day and night and go crazy, but it's
like Super Weather Channel.
only this is the real thing. There's no
commercial.
There's no biases. You know, the pilot says I lost an engine. He damn near lost an engine, you know. He didn't spin it. Like, oh, well, you're just having a turbulence.
You got another question?
Yeah,
Go ahead.
Yeah, quick question.
Yeah.
What antenna are you using? Looks like it's a really wideband system, or you?
Yeah, it's a wideband discount antenna. So it's a vertical with radios
Yeah,
and it's on the roof. I think it's around 35 foot roof. So it sits above that. So it's small. It's not that big of an antenna. It's not directional, which means I get all the New York, 250 miles out I can pick up. So you do Hamilton Square to 250 mile radius around it. I see it all, man.
You can get a lot of FM stations.
Yeah, it's great for FM too, which is available on this stuff too. Okay, so let me go back to the speech. Oh, here's the PowerPoint. All right, so I can let that just run in the background.
You can just listen to NPR, fresh air on.
Don't listen to NPR.
quadrasonic, right?
Okay. Do you believe any of these? I don't know. Do a little test sometime. It's amazing how much they're lying to you.
Oh, yeah, we gotta talk about the drones.
Yeah,
and the
let's go to the drone. So this is cool. So
If there was a mothership, you would have found them already.
I got a good one though. I did find, well,
Yeah.
December 11th. Jeff Van Drew kicked off the New Jersey. Hey, there's an Iranian ship. And there's drones coming from the Iranian ship and they're going home at night. They're going back on the ship. And then so the president says, you're crazy, you know. But so then everybody's seeing drones. I mean, I joined the crowd of going outside with my high power Nikon binoculars. And there was something going on. Now, coupled with this, I didn't have this running at the time, but this would have been great because I could do an overlay of the actual video of the planes up ahead, the lights up ahead, and how far they were from my antenna. And I could say, that's that guy, that's the.
That's gotta be it, yeah.
But my chances are there wouldn't be any tags on it, right? They probably shut it down for that. But anyhow, it would have been an interesting experiment, but I didn't have the time and my wife was yelling at me. Get back in the house at 3 in the morning, you know. But anyhow, there were some strange objects and they weren't in a flight pattern. I mean, you want to see some flight patterns. That wasn't a flight pattern. They were just paused for a long time. Really odd, really odd. So anyhow, finally on January 29th, the president said, they're ours. They're for research. And, but in the meantime, I'm digging, right? So I have my sources of military contractors. Now it's all public domain stuff, you know, they're starting to sell things, right? So you go to find some people who are selling drones. Well, what are they selling? They're selling not necessarily drones, but there's a whole entire corporation selling counter drones. You know, in this particular case in New Jersey, you had, well, what they listened to, they didn't listen to anybody. Now, the mayor of a town come in and they're like, don't worry about it, just go home. He says, I drove all the way from northern New Jersey and you gave me nothing, Homeland Security at the Rock, you know, you got nothing. He's mad, he gets in the press, he says to the press, they're a bunch of idiots, they're telling me nothing. So they're mad, the congressmen, the mayors are all mad, except the one thing I found out what the Pentagon listens to. The officer who manages, what's their title? I'm not a military guy, but the guy who manages Pickaninny Arsenal, he's a big shot, right? And then Earl is the Navy. You know anything about Earl?
Earl, the Navy weapons base.
The weapons base, yeah. So they're both, commanders are both calling the Pentagon saying, hey, this is no bullshit. I'm seeing drones. There's drones. You know, my base is at risk. What are you going to do for me? So I stumble upon the Pentagon making not only an announcement, wait do you see what the Pentagon says? That's my next slide. This is a good one. This one's crazy. Where is it here? Okay, Major General Pat Ryder, the Pentagon press secretary, said the military is providing active and passive detection capability and counter drone capabilities to Pickaninny Arsenal and New Jersey Naval Weapons Station Earl. The Pentagon sent counter drone weapons from the corporation DIZE.com. So go look at DIZE and they have counter weapon well, probably you can't buy, but, if you're, if you're in charge of Picatinny, you can, they deliver, and it's training too, so they'll deliver people. Anyhow, I found out one of the government publication that despite what president is saying, it's nothing to worry about. Why are they sending counter drone and counter drone operators to Picatinny and Earl? Why? This doesn't, what do you call that?
It's a cognitive dissonance.
Ah, thank you. So, yeah, I have no answers on that. It's crazy. But the good news is once, all you need to do is give me the name of a company. And then we can go crazy on that, because then I can go see what the company's about. So I just go to their website, you know, they're very helpful.
Yeah.
So this is their counter drone equipment.
We'll make this big so people can read it.
Yeah, this is a good one to read. So can you read the print on here?
Here we go.
So they call it, of course, a drone buster DTIM kit. What a name, right? You think this is a joke, but it's anyhow, detects drones up to 7 kilometers. Effective jamming, optional PNT attack mode. So what does that mean? Well, we know what jamming is. Jamming is I can't get location. There's no command and control to a drone. If I can jam the CNC, the drone does one of two things. It parks, it sits down and gives up, or flies back home to mother. One or the other. It's either programmed to go home or just land. Am I running out of time? This is good stuff.
Yeah, you're good, you're good.
All right.
Again, another 10 minutes and we'll.
Yeah, so here's a lightweight wearable and attack compatible. I have no idea what that means. ATAK compatible for seamless handheld, mobile, and fixed site configurations for layered defense. So here's the big deal. So we know what jamming is. Jamming is just noise and there's no command and control. So it's got to land or go home to mama. An optional position, navigation, timing, that's spoofing. That's not jamming. So they're giving a fake coordinates of GPS, GNSS to be polite or proper. So it's telling it, hey, this is where you're at. So it's giving them fake coordinates. Which they can maybe prompt a response by giving them programming in. You can program in a latitude and longitude data points where it thinks it's at. And it's not, because you've got they basically are simulating satellites. You have emulating 3 or more satellites generating the signal. Easy to do. And one of the things you can control the phase, frequency, and amplitude. And then you can capture with amplitude, you can capture the GPS. So you basically take over their GPS by just setting the right level. Why is that? Because GPS signals are very weak. So subject to jamming, subject to spoofing. You can buy it with its own internal satellite, fake satellite built in. Anyhow, that's pretty cool stuff. So that's what they delivered. I don't know what you think of that, but that's pretty crazy stuff. I don't know.
Yeah, you should be able to use that.
What's that?
We'll edit that out, don't worry.
Yeah.
Really quick, so HVAC is a program, it's largely run on Android, so it's basically like a battle space mapping program.
Is it?
People will mesh all their radios devices together to share,
Yeah.
usually coordinates and offers and stuff.
Yeah.
You control and information and live video back from them.
Yeah.
So everybody wants to try to get everything they can into ATAC, even though it maybe is a little clunky.
Oh, I'm glad you looked that up. Thank you very much. So anyhow, there's no answer to that. Why would, again, the Pentagon responded. Then I started looking at what's going on in Ukraine, and everything lit up like it's Christmas. It's Christmas with a lot of dead bodies, unfortunately. So Ukraine is, like I say, everybody in building drones in Turkey, China, UK, all over the world, they're using the test field, the blood field of, isn't that what they used to call it in World War II?
Yeah, yeah.
Bloodlands,
Yeah.
which is Ukraine. And it's drone and counter drone. Russia's got some advanced technology. So What do you think they have? So if these are detected by an electromagnetic signature, I know what drone it is, right? Easy solution. So let's just string 6 miles of thin fiber optic, and we'll have a fiber optic command and control. That's what they're doing now. So they're shipping a lot of fiber drones. So you can't, it's harder to detect. I'm not saying you can't detect, but, so I don't know, it's just terrible. I mean, they gotta end the war. There's just too much. But in the meantime, the armament manufacturers are having a field day doing field testing. This isn't simulation. This is the real deal. They're out emulating, killing people. One of the latest tricks I just heard the other day is that the Ukrainians have a sub. So they must have some green-blue laser. They have a sub that took out a fighter, a Russian fighter jet. So apparently it was able to send a laser weapon to nail the Russian fighter jet. I don't know the details, but that's just came out on one of the military channels of news, kind of informational. So this is a hot thing. It's all the journals are just every issue is drone galore. It's from a lot of sources. They are predicting drones are going to be what's being used in the World War III war. It's going to be a drone war.
Yeah.
And
So
it's more
forget
than one.
AI, it's drones.
Right, it's more than one Gnostic predictor saying it's going to be a drone war. So it pays us to at least keep track of it, Okay, so just a couple, or we should want to wind it down. This was odd. The other day, I had this thing on, and then I was plotting the position, and this was over Airport here, Trenton. Yeah, so this is a small craft that's flying like this continuously over Trenton. I don't know what they're doing. It wasn't during the day, so otherwise I would see if they're blasting chemicals in the air. I don't know if you knew the latest stuff on that, but apparently there's some state of Florida is going to be banning chemtrails. And poor Bill Gates wants to use it to cool down the earth. Only I wouldn't spray nanoparticles of aluminum if I was going to do that. If I wanted to make people stupid, I would give them nanoparticles of aluminum that are, they're neurotoxic nanoparticles. But anyhow, that's getting off the subject here. But that is a weird behavior, just to go around in circles unless there's some kind of training going on. Okay, any questions so far? Let's see what else I got on this thing.
Yeah, we'll wrap it up in about 5 minutes.
Okay, so yeah. Oh, he's just testing it.
Yeah.
So on the 50th circle, damn, I knew I was right.
Probably the mechanic, like, really gotta fix it.
Yeah, it's a small craft too. What plane is that? Yeah, interesting. Look at it.
You're already down to go.
So this shows his speed as he's making the turns. He's got a sine wave up as he goes around the corner. You can see it, literally a sine wave.
That's one direction.
You're gonna calculate from that what talk about sine waves. So the answer on ADS-B, which is the latest airplane knowledge system that's transmitted wirelessly, the latest thing, they want to put a signature in it. So they want to put a code, bury a code inside the RF spectrum using a Fourier transform. They want to insert a unique coded string that would indicate it's authentic, right? So the authenticity of that plane was, so that's what they're thinking about.
Like the dots on a dot
Exactly.
matrix printer, they're used to identify the unique printer that
Right. They
that
call it,
printed the document.
well, there is something in the Microsoft Office that IDs. Is that the dots? Is it the dots that the Microsoft uses to ID it?
I don't know.
Because they got the who's that guy that was a killer? He sent something with a typed note in Office.
Yeah.
And they looked at it and sent it to Microsoft. They said, here's the location of the computer this guy printed it out from, And then they busted in and they found the what's his name? BTK killer. The guy that got away like 25 years ago.
Yeah, that's right.
And Microsoft Office ID turned him in, gave
It
him.
wa- I think he was
Should
in
use open
Kansas
source.
City.
What's that?
I think he was in Kansas City.
He was Kansas City, yeah, but he escaped getting caught for so many years. It blew my mind.
Yeah.
He was the animal control guy, wasn't he, in charge of animal control?
Yep, that was one of his jobs.
Yeah, but I almost flipped when I thought it was Microsoft's ID on a piece of paper.
And it was from his church.
And it was his church, right? It was located and.
Yeah, he was so trusted that they gave him what access any time of the day or night, and he went in and helped them in the office.
I completely fell off my chair when I saw that he was, they surrounded his church. They watched him come and go a few times and they said, oh, he's a deacon here at this church. And that was the BTK killer. Nice. Can't trust anybody anymore.
All right. Thanks for that, Nancy.
Mhm.
Yeah, thanks, man. Okay, so anyhow, I promised I'll tell you what it was. Automatic Dependent Surveillance Broadcast. That's the acronym. Automatic Dependent Surveillance Broadcast, ADSB. So this is what they want to put on every plane. This wants to be the latest generation of tracking and control. So it combines the aircraft's positioning source, aircraft avionics, and a ground infrastructure. So they want it on every plane. Now, in case you haven't had enough of this good stuff, let's suppose you're not interested in airplanes, you're interested in ships. Well, AIS is also decoded on this. That's your automatic. In some cases, you can replace radar on a boat, on a ship. Let me show you what that looks like here. Let me go back to the program. Where is it?
Use the arrow keys if you
Huh?
want. Use the arrow keys. That'll get you back. Yeah, there you go. That's faster.
Okay, thanks. Yeah, here we go. All right, let me just show you this before we call it a night. Come on, go back.
You're not on the internet. You're on the slides.
Oh,
If
okay.
you want me to switch back, I can
Yeah,
do
just, I can't see very well.
That's
Getting
fine.
too old.
that. We gotta escape, and then back to here. There you go. Now you can.
So these crazy guys in Germany wanted to do, look at all these protocols, check it out. AIS happens to be the major ship. So I click on AIS 1, that's where I set up the decoder. It goes on AIS. These signals on the right is just the NOAA voice, the NOAA weather. So 7, 8 NOAA weather frequencies. Let me see if I'm getting anything with AI. Oh, there it is. Okay. So here's North American Coast Guard Station. Anyhow, so you can watch, it's very busy if you get to shore or you get close to Baltimore. This thing just floods. Like you'd see airplanes, this thing is ships, but you see all worldwide ships. And company I worked with for a while was long time was Orbcom, and they decided they got a government contract to capture all the ship location in the world because they hijacked. They put a card in. They put a card in to track AIS transmissions and relay it over their satellite system. So they can be over the Straits of Hormuz and in real time see a little bit of latency, and they can see where their ships are. So customers like Exxon and BP are big customers because they know where the ships are in real time. And this was originally designed to be a safety, broadcast. Basically, look, I'm here, and I see it coming in and out of the Delaware River. I see ships, really good sized ones, up and down the Delaware River. There are some large windmill turbines they move in Bristol, Pennsylvania, and they move it out on the Delaware because they can't ship it by truck. They're too big, the blades. Anyhow, hope everybody found this interesting. I'm going to wrap it up. Thanks,
Yeah,
man.
thanks, Joe.
Yeah.
And we'll take some questions if And I have a microphone here,
Did
so.
somebody asked me earlier about the hardware, so I mentioned I started with Linux. I ported it over to the Raspberry Pi. And then I was running it, it runs perfectly on a 3B. Well, a 3B Pi is quad, it was the first one of the first quad core architecture. So I thought as a lark, I'm gonna take the Raspberry Pi Zero 2W, second version of Zero. And that's what I'm running everything on. It looks like this. This is a copy of what I got on my system in my lab. Pass this around.
So it's littler, but it's still as powerful.
Yeah, so it's a quad core for $15. And it runs. I have the actual software installed. On that one, what I said is I don't want to go on my network. I want it set up as a server so I can go do it locally. So when I'm watching the airplanes, I can be watching it directly from this as a receiver, SDR receiver. I could take in my machine, any of the tablets with a browser, I could talk to it directly. Now I could go to that IP, that generates its own IP. Right.
With
Two.
an antenna perched on your roof.
Or handheld. Well, I would use a handheld if I'm looking at the up ahead. I'd aim a little slightly directional. Yeah, right.
SDR in.
Yeah, $15.
That's the.
For $15 and SDRs are like $35.
Small weekend project.
I know. Would it be good projects? Yeah. It could be a good, because ACM doesn't sponsor hardware projects, right? IEEE does.